any other questions that you'd want to know on the...
Okay, yeah. The next set of questions will be really on the capacity for this system, and just a brief explanation on how you did the load assessment and what mitigation was there at the time that there's no sun. Because I know during the day you can do anything that you want and so on, and like I can see here, the battery is full.
Yes.
And obviously,
so when we started talking with the client, we asked what is the current load that they have where they are staying. So on average, the client is able to use about 10 kilowatt hour per day. And then apart from that, we also asked what are some of the loads that the client is expected to have, that is here where they will be shifting. So one addition that was there was the pump. Because in this location, we don't have Mlonga water service in the area. We don't have ZESCO bringing power to this house. So that was the motivation to actually implement the system. So once we looked at that, then we also did a forecast to see if there is expansion or they are using all the 4 stoves, the 4 plates on the stove, or they are doing any grilling. And then also, if the client uses 10 kilowatt hour, then there should be the autonomous hours or autonomous days. So by 17.6 kilowatt hour, we actually provide 7.6 kilowatt hour additional in case there is no sun. But as you know, in Zambia, we have got, at least when the sun is not there, we could have up to 3 to 4 hours of sunlight. So with the system capacity in terms of solar panels rated at 7,000, what we foresee is the load for the house actually being supplied direct from the solar panels during the day and only using the storage in the night.
okay.
Yes.
Thank you very much. And was there any education to the users on how they can prioritize the roads, or with the calculations that you made, there will be really nothing like they have to prioritize the road, or like they can use at whatever time they want all the loads?
So the system design considered 2,000 watts of cooking. So meaning at every point of the day, if they are using 1 plate on the cooker, that is not a problem. And then with the pump, we've incorporated the control aspect, meaning when the level falls just even by 1,000 liters, then the pump should kick in. So it's a situation where, of course, we educated the user on the do's and don'ts. But then what we have is lithium-ion battery, which basically supports all kinds of loads. And then when we come to the arrangements of the inverters, what we have is each inverter can give us a short time power of 10,000. So we are talking about 20,000 watts worth of loads for this system to go down. So it's not something that we foresee. But on the worst case scenario, we actually simulated a scenario where most of the roads are working and the system was able to support. We had about close to 6,000 watts of load on the inverters to actually simulate when maybe they are using a lot of heavy loads concurrently, and the system is able to support. So what it actually tells us is that with this current configuration, the client does not have to worry when they will have utility near and all that, they go on with their normal of life. They have got power there, they are able to cook, all the roads are able to be supported with the system.